Our topic today is innovation from lab to market. We have three distinguished speakers with us: Michelle Jiang, Emerson Xiao, and Louis Hong. Michelle is the co-founder and managing partner of Impact Science Ventures. Previously, she was a venture partner at ITIC, ITRIS VC arm. Before turning to venture capital, she was a three-time founder and CEO, CCO, CMO of hard tech startups with successful exits. In addition to having been a founder of 3 startups, Michelle was also an executive in corporate development and strategic planning for large public companies. Dr. Jiang earned her PhD degree in electrical engineering with minors in physics and material sciences from UC Berkeley, and her Bachelor of Science degree in electrical engineering from National Taiwan University. Emerson Xiao is the COO of Andes Technology USA. Dr. Xiao has an extensive background in the ASIC and IP industry. Prior to joining Andes, he worked at Kilopath Technology as a VP of marketing. He had also been the general manager of Faraday Technology USA, where he spent several years in field application in various locations, including Taiwan, Japan, and United States. Prior to joining the industry, Dr. Xiao was a visiting scholar at UC Santa Barbara and has received his PhD degree in electrical engineering from National Taiwan University. Louis Hong is currently the founding partner of FP Solutions. Louis has an experienced operations leader and entrepreneur. He previously held positions as Senior Manufacturing Manager at SpaceX, Director of Operations at Romeo Power, co-founder of Bento King, and was also the principal at OLE Consulting and Production Leadership at Epson. Louis received a bachelor's degree in mechanical engineering from Stanford and an MBA from Oxford University. Now to start, let's discuss bringing hardware companies from 0 to 1. And one of the important questions is, what are the key ingredients of success for hardware companies, and how do these make up different from their software counterparts? Michelle, why don't we start with you?
All right. Hi, everyone. I think maybe you thought I was done with the stage, but here I am. Hello. Well, I think my first comment, actually, this is not necessarily hardware specific, but just startup in general. It's really, just when you are thinking about starting a company or investors, looking at investing in company as 3 things, right? It's about technology, team, and market. Oftentimes, or actually, when you start a company, really perhaps it's the reverse. You really want to think about, meaning market, right? It's really, is there a problem that big enough that's worth starting a company for, to solve? Because it's the one thing about technology founders, and maybe to a degree hardware company. So oftentimes it's like technology driven. So it's you have a hammer and you're looking for nails, and then at some point everything looks like a nail. But really, what you want to do is really the reverse, right? Finding out, are there big problems that's missing solutions, and then from there, matching that. Hopefully, of course, likely you're going to start with technology areas or space that you're familiar with, and then find a team to build around that to bring a solution to market. So unique challenges, I guess I kind of mentioned, right? Just finding the market, and then finding that and figuring out the first kind of product market fit. It's being one particularly challenging for hardware because it's so much easier to bring like an MVP in software, with like limited funding and maybe like small team, and you can like just write some software and get the code released quickly, and then maybe like giving it out for free as well, to get some trials and users. But hardware does require usually a lot more capital, and then development time, resources, etc. So that's kind of a unique challenge for hardware.
Thank you, Michelle. Louis, do you have anything to add?
Well, let me take a quick poll first, okay? And let's see, let's understand our audience. So, who's an entrepreneur here? Raise your hand. All right, great. Keep those hands up. All right, great. Who's a hardware entrepreneur? Oh, okay. Better than I imagined. Okay, maybe this is Taiwan, Silicon Foreigns. I was expecting no hands. Now, not to diss kind of software kind of entrepreneurs out there, because after all, we are in Silicon Valley. But hey, when your app doesn't work, you might go, oh shit, right, this piece of crap, right? But when your hardware doesn't work, you may become a piece of crap. Okay, so I think beyond, like for software startups and hardware startup, I think the additional complexity, like Michelle mentions, really understanding and have a defined problem map, make sure you have a very clear product market fit. I think there's also additional kind of complexities, when it comes to hardware that deals with supply chain, the way that industry dynamics, how it really plays out, as well as, kind of IPs and all that on top and regulations, for safeties. I'll give you kind of a perfect example. We came across recently kind of a deck that was forwarded to us, kind of by a top tier kind of VC. This company is doing sustainable primers. Okay, so they're targeting the $1 trillion per year primer market. Now, in the VC's eye, okay, perfect. Everyone's drilling. Oops. Everyone's drilling over kind of this possibilities. Right, the tech is the CMU professor's 20 years kind of worth of research. The tech stands, and there's a clear product and there's a clear need, and they want to go out there. They want to revolutionize the way that primer is being applied, kind of in automotive industries. Okay, so all in all, on the surface, it makes sense. There's a problem, it's big enough. There's a solutions. It seems to fix the problem. Now, what is the issue here? Now, most people may think that primer companies are technology companies, but what indeed, coming from the industries, all the paints and primers, really, you're a service industry. Okay, the companies, if you understand the paint process, this is a 5-layer processes. Okay, by solving the primer itself, okay, nobody's really going to adopt and invent kind of the R&D to just substitute a primer and gone through that entire qualifications. Now, furthermore, companies like of Tesla's, these days don't really do any of these paint kind of inventions themselves. They completely outsource it, to these huge kind of paint companies, conglomerates out there, and that's why we have almost like a virtual monopoly kind of out there. So this is kind of the super in-depth, I would say, understanding of industry, product market fit that entrepreneurs need to understand, beyond, just obviously gauging kind of the problem scales, and other stuff kind of for product market fits.
Thank you, Louis. I think both Michelle and Louis touched on some of the unique challenges and opportunities in hardware company. I would like to ask Emerson to comment on how do hardware companies overcome these challenges?
Yeah, so before I say anything, I kind of want to redefine hardware, okay? It's called hardware because it's hard, right? So I think there's a major difference between hardware and software business. Well, on top of all the things that Michelle and Louis talk about, right? You want to find the right application, right problem to tackle, right? But hardware business is also you also have to focus on executions. So you look at the hardware business, right? Let's say I'm primarily in chip business. And then particular chip business is very difficult to do because that, let's say you make a mistake, right, in the software, and then you probably fix that in days, if not hours, right? But if you make a mistake before a tape out, right, so what you see is a crap that Louis just mentioned, right, at the end. And what happened to that? That means that you have to wait maybe another year to get a silicon again, and that will probably waste you millions of dollars, right? And then you probably 1 year late from time to market, right? So it's very challenging business. And then the execution I mentioned, right, pose challenges across the board, right? It's a challenge to VC company when they decide to invest in hardware business, right? And then it's challenging to those people that work in the hardware business, right? Because you do need to have perfect executions. And all of that, right, really challenge for hardware business, right? Yeah.
Thank you, Emerson. So given those challenges, how can VC or even the government help? Michelle and Louis?
Well, that's a good question. Well, I think, well, first of all, so in terms of VCs, so obviously, VC will invest in the space only if they are interested in, even though it's not necessarily an area they are they're actually knowledgeable of. So in a way, when as an entrepreneur, when you are fundraising, talking to investors, actually you should really consider this as a kind of mutual selection process where the VC is looking at you, evaluating your business plan, whether it's a team that they want to invest in, and likewise, as a founder, you should really look at the investors that you are talking to, understanding what's their value, value add to you. Obviously, capital is great, so like all money is green, but really, the best investors for you are people who can bring additional value to the table. Things like having hands-on operation experience or domain expertise that can maybe help you navigate some of the issues that you either as a first-time founder or even experienced founder, but maybe in new space or face new questions. Perhaps the VCs can help you with either their direct knowledge or through their network to help you. And in terms of government, obviously more funding in the space. So yeah, for example, like the U.S. government recently passed a number of acts in the space, right? The CHIP Acts and then the Inflation Reduction Act to support the development of new innovation, bringing the technology to market. So I'm actually not super familiar with how much funding that the Taiwanese government is providing to innovation startups, but certainly hope that if we really want to promote innovation, especially in the hardware space, where sometimes the risk capital early on is a little harder to get. So bridging this lab to market with the non-dilutive grant funding from the government is actually super critical. It's like partly like in our investment thesis, we want to try to leverage that, and then there's plenty of that in the U.S. and then hopefully the government in Taiwan will consider similar.
Yeah, I think Michelle hit it right on the spot. I think I completely agree that VCs. It is VC's responsibility and missions, right, to provide that added value to all entrepreneurs out there. I mean, we started FP Solutions with that specific goals, specifically in hardware startups, because historically, hardware startups don't really get a lot of love. Now, I came from SpaceX. I spent 7 years over at SpaceX, worked with Elon, to build the first rocket factories, and went through that 0 to 1. On the crazy, out of this world journey. My partner came from Tesla. Now he was looped in by Elon, to turn around the whole Model 3 production hells. So both of us have gone through that 0 to 1, hell, so to speak, and we completely sympathize with all the early stage entrepreneurs and especially hardware entrepreneurs out there. And that's why we started FP Solutions. So I 100% agree with Michelle that it is VC's responsibilities and I think missions, to guide and support their portfolio companies and provide the added value.
Thank you, Louis and Michelle. So one particular question for Michelle is that you have co-founded multiple companies and those are coming off of Berkeley's technology. Do you see Taiwanese university create a similar pipeline for hardware startups?
Sure. So minor correction, though, the second startup was technically not a Berkeley technology, but me and my co-founder were both, PhDs from UC Berkeley. So so in a way, it is, we came up with the ideas. So it is based on our education. Absolutely, I think there's, just as I talked about this idea of female founders have equal, similar, same good ideas and capability as their male counterpart. Same thing, right? People in Taiwan can have as great ideas as what they have in the U.S. Even though it's perhaps true that in some areas, there's less advanced, really cutting-edge, technology being developed outside the U.S. But I definitely think that there's opportunity for innovation and for kind of hardware, science-based innovation startup coming out of academia in Taiwan. But so perhaps the environment there are some minuses, in terms of, we talked about government funding. I don't know if it's equally available there, and also risk capital. My experience with the VC industry in Taiwan is a little bit more conservative than in the U.S. And then maybe as a result, also less of an environment to help these founders, because again, founders and especially first-time founders, and in the hardware, hard tech space, have some unique challenges, and it's really helpful when you have like a peer group to help you to kind of learn and kind of discuss, bounce ideas off, etc. So there's a lot of programs here in the U.S. Kind of focusing on different type of spaces, or maybe like hard tech in general, a specific type of incubator. Looking for those type of programs in Taiwan, or if there isn't one, start one, like what Louis is trying to do. I think those are the things that can be helpful to a Taiwanese startup to build that innovation system, especially in the hard tech space. People in Taiwan do have some advantage. First of all, I feel like people are pretty entrepreneurial in general, right? It's always like people super creative about solving problems, sometimes maybe in unconventional ways, but and people are really good at doing things quickly. And then the second last thing, maybe I mentioned that I talked about a lot of a company that we look at investing in the U.S., start out making things here, but when they are scaling, they need to go to Asia. Oftentimes, lots of opportunity to do that in Taiwan, because it's just in terms of scaling up manufacturing hardware, there's just so much more knowledge in the complete supply chain there, and also cost is lower. So the U.S. startup had to like go from here over there, and in Taiwan, you're already there, right? So you do have advantage of just being where manufacturing technology and supply chain is really very strong there, and hopefully you can take advantage of that and promote it and get more hard tech startup out from Taiwan.
Thank you, Michelle. Kind of tying into what Michelle just said about Taiwan is very good at manufacturing and scaling up. Another question I have for Louis in particular is when do hardware companies generally fail? Is it during this product market fit period? Is it during scaling up, or is it other stages of startup?
Well, product market fit, certainly is, like I would say, one of the most important, if not the most important kind of thing that companies need to get right. Solving, like Michelle said, real problems. Really, and then I kind of emphasize understanding industry dynamic and making sure that the solution actually makes sense. I think it's the overall directions, right, for startups. Now, to go with it, scaling, at that super early stage is more or less an art. I think scaling, and software is already hard enough. When you factor in kind of the elements of supply chains, and the cost, it's just because hardware is so much more expensive. Your margin for error is significantly smaller. Okay, so not only do entrepreneurs need to plan out, kind of really thought out kind of that scaling strategies, but at the same time, it is very important to have, kind of the iterative product strategies rather than trying to get the product right the first time. I think Elon used to tell me, kind of very importantly, like, don't imagine a problem that does not exist. Okay, don't try to create a perfect product because you don't know what a perfect product is. Okay, go out there, iterate, and learn, and then go from it again. I think it's very critical for hardware companies not to delay, for a perfect product only to miss the market, kind of shortly. And I think SpaceX is a perfect example of that. Here's the little secrets, for people that don't, the inside secret for SpaceX. So no two Falcon 9 rockets are actually alike. Okay, I will bet my $100 even this day, no two Falcon 9 rockets with the design frozen for so long is exactly alike. At SpaceX, I call this dynamic manufacturing, okay, in which as soon as a launch takes place, the lessons are learned, incorporated, designed, and already injected in the middle, kind of manufacturing. I wouldn't call that's best practices, okay, but that's definitely kind of, like, as they call it, right, ready, shoot, aim, they definitely took that to the next levels. And I think that's very, very, that agility and that ability to respond and adapt, I think it's very, very critical, for hardware scaling at a real early stage.
Thank you, Louis. Next, we'll present a prime example from innovation from lab to market, which is RISC-V architecture. And we will ask our expert here, Emerson, to tell us what RISC-V is and what its impact can be. Can we please switch to the next slide? Can we please switch to the next slide?
Okay, so it looks like we have another technical issue here, but I'll just go ahead and explain what RISC-V is. Okay, so it's a very popular buzzword these days, and then it also originated from Berkeley about 2010. It's a school project. It's a small project in the beginning, and I don't know if everybody's kind of aware of this terminology called RISC. RISC is basically a CPU instruction set, right? And then what started in 2010 in Berkeley is that they're looking for a new instruction set architecture, right? That has three basic primary characteristics. One is that very small and simple. Look at the Intel or AMD right now, or ARM right now, right? So the instruction set is very big, it's very complex, and they set out to design a new instruction set that is very small, and yet it's very modular, meaning that it has different modules, right? You can plug in, and then you can do all the things that you want. It has a lot of flexibility. And then on top of that, what they're looking for is something that everybody can use, which is a game changer in this case, because when we look at the existing instruction set right now, let's say from Intel or from ARM or AMD, you can buy product from them, but you cannot develop product that is comparable with them, right? That's one of the bigger issues. And then what they aim for is that, can we design an instruction set, right? So everybody, it's the same instruction set, and everybody has the right to use the basic idea of open source, right? So it's an open source instruction set that allow all the designers, oh, there you go. So it's an instruction set, right, allows all the designers, right, free to use that instruction set. So you can say, okay, I'm going to design a processor, right, that is compatible with RISC-V. And then because you're compatible with RISC-V, right, you also compare with everybody in the same community, right? So that's what they did in the beginning. But, prior to that, there are a lot of instruction set. It's already existing in the market, and none of that actually succeeded, okay? And you wonder why RISC-V will take off, right? And then I think the second factor happens 5 years later, not in 2010, right? Was an organization called RISC-V International. I don't know if anyone heard of that. It's an organization founded in 2005, and they're dedicated, it's an organization, nonprofit, dedicated to promote and manage RISC-V instruction set, right? And today we're in 2022 right now. It has more than 2,000 members in more than 70 countries, right? So it's just getting so popular that So in fact, I would say that if, let's say 5 years ago, right, you say that you're going to join a process company, right, a startup, right, or say you're probably out of your mind because there are only a few process companies, and those are all very big, right? And because of RISC-V, right, it created a platform and opportunity for innovation. And right now, there are tons of companies that are working on RISC-V, the process itself, the ecosystem itself, right, and all of that. It's coming to a time that will fundamentally change the semiconductor ecosystem. So imagine that how many processors you have in your pocket right now. Take a guess. There are many of them. At the minimum, you're talking about 50 to 100 processors running in your wallet right now, right? And then most of them are Intel or are ARM-based. And we're to a stage right now we see that a lot of them, or maybe half of them, will go into RISC-V going forward. Okay, and that's kind of where we are today. Can we have next slide, please? And why it's so providing all the opportunities, right? So I'm just do a very simple comparison, right? And then I'm taking this slide out of the RISC-V International. Right now, right? So the complexity is that the legacy ISA has so many instructions. It's very difficult to implement to begin with, right? And then you don't have the legal right to use freely, right? So so when RISC-V started, it has only 47 instructions. It's very small. It's tiny, right? But it's modular, meaning you can always add more stuff into it. It's very tiny, but it's very flexible, right? And then, like I said, if you want to design a compatible processor, you have to license, right? But RISC-V is open source. And then Berkeley, well, appreciate Berkeley. They really embrace the open source concept, right? Everything they do, they really open source it, right? So it's free, and you can do whatever you want. You can develop your process based on the instruction set, right? And you don't have to pay license or royalty, right, to use that instruction set, right? And then it's been 7 years right now. The ecosystem is growing really fast compared to the existing solutions. So of course, you guys, you have one-stop shopping. You got a very good solution, very robust, right? But the RISC-V also has a very fast-growing ecosystems, and then it gives you all the flexibility that you want, right? And so the same thing with the software ecosystem, right? So we don't see any servers or mobile phone that using RISC-V today, but I can imagine that that's 3 years, 5 years down the road. Down the road, you will see some servers or the mobile phone will be on RISC-V. And then we're in just the process of building that ecosystem right now. So that's a very short brief on the RISC-V.
Thank you, Emerson. Like you mentioned, CPUs are in our mobile devices, are in our laptops, are in server racks, are in IoT devices, and like automobiles. Given this wide application of CPUs and what RISC-V can potentially do, what are some of the business opportunities opened up by RISC-V?
Yeah, that's a good question. So CPU is not one product. CPU is many products. And what I meant is that when you say I'm going to use a processor, right, you don't just use that processor hardware, piece of hardware, right? That's just very bare bones, right? And then you need software, you need a compiler, you need debuggers, you need the operating system, right? And then you need application software, all of that, right? So typically a new instruction set architecture does not compete with existing products. Let's say for example, right? Let's say a modern hardware, right? So it's very the cable modem hardware. It's very mature. It's very it's been there. Everybody has it, right? It's 20 years, right? Has a lot of software running on there. Right? So that's not where the new instruction architecture can compete. Where this RISC-V provides that, like I said, a platform, right? It's very flexible and easy to innovate, right? And what happened in the past 5 years, right? There's AI, right? And there's 5G, right? So those are what we call key applications that happen alongside with RISC-V, right? So we talked about AI in the previous talk, right? So it's innovation everywhere right now, right? And then people are just trying to find all kind of ways to differentiate, right? And it happens that RISC-V provided differentiation to those emerging applications or market, so where they can really, I mean, it's not a right word, but really they can do whatever they want, right? To really differentiate, right? To really show that they can be better. Instead of, if everybody buy the same solution from the same company, right? And everybody will look the same, right? And that's not how AI works today, especially at this timing right now. People really want to differentiate, and RISC-V happens to provide that differentiation, and that's all the innovation is happening. I mean, combination of AI and RISC-V right now, and also 5G too. 5G is in an area because it's also coming really fast, and then you need a lot of hardware and software platforms, and RISC-V happen to provide that capability. Yeah.
Thank you. Since we're at Taiwan Tech Summit, I wanted to ask something specific about Taiwan. What are some advantages and disadvantages of being a Taiwan-based company in CPU market, given that that market is mainly US-based?
Okay, that's a great question. Before I answer that question, I'll give you some history of my company. So my company is called NATEA Technology. So we started in 2004. And then 2015, that's 11 years later, it's the first time that we break even. That's 11 years, right? So when I say earlier that it posed a great challenge to the VC, that's exactly what I meant, right? So I mean, I'm not sure I state this correctly, but I would say that no VC in right mind will invest a company like Endis, right? If they know it's going to take 11 years to succeed, right? Okay, and then, so 2015, the first year we break even. 2017, we went public, and then now it's really a thriving company that has a very good success in RISC-V. And then go back to that question, right? So then earlier we also touched upon the government funding, right? And I would say that, initially the company is partially funded by the National Development Council, the National Development Fund, 国发会, okay? So, and then imagine that it took 11 years, right, to break even. So what happened during that period, right? And then how the company can survive. And it's a good reason. It's not excusing issues that it took 11 years to break even. It's just how takes to develop a CPU product, right? So, like I said, it's not one product, it's multiple products. You need to have the processor, you need to have all the software, right, and the OS, and then once you ship your product to your customer, right, and they take that product into their product, right, and then that's another 3-year cycle, right? So you have 5 years development, and then 3-4 years, right, another 3 years to really accumulate enough revenue so it can break even. It's just how long it takes, right? And it's very struggle in that 11 years, I would say. And luckily, we have the National Development Fund provide a steady support to the company, right? So we can survive and then later thrive, right? After 11 years. I think that's that's, if I look back right now, it's really a key factor. And I really appreciate, I don't know if the National Development Council has any people here, I really appreciate their help and support, right, during that struggling 11 years, right? That's kind of one biggest issues, right? And then we kind of overcome that. And then the second one is that I think we also kind of touch about that the hardware business, right? It's so expensive right now, right? And it's so prone to error, right? And then any mistake really take a long time. But in Taiwan, it has all the, it actually has all the advantage, right? So you have the talent pools, right? And you have the supply chain all clustered together, right? And then you have the government funding, right? Of course, they don't fund every company. I mean, I'm sure that's a very selective process that to select which company they fund. And also, these ingredients, right, provide a perfect environment for how our company to start to begin with. So those are the kind of the advantage, right, being a Taiwan-based company that in the hardware, particularly in the CPU business, right? And then, what about, is there any challenges? There are challenges. The other I want to mention is that the talent pool. Okay, so particularly, I know every scenario is different if you're in a different type of hardware, you see different problems, but and definitely talent pool is a very big one in our business, in our line of business, processor. Historically, Taiwan is not, doesn't really have a lot of processor experience in the past. There are only 2 or 3 occasions that there are people working on a processor, but it's all like 20 years ago, right? There's not really a lot of talent pool in Taiwan. So, and that's kind of the limitation that we have today, right? So in order to go global, right? So we are kind of doing really well right now, but in order to global, so we really have to step up, right, to increase our talent pool. And that's why, so I'm very focused on expanding that talent pools in the US right now, because that's kind of the most critical challenge that we have, right? So to summarize that, it's the government funding, right? And it's, oh, that's not mine. Okay, there's a government funding, right, provide a steady hand. Okay, and then the talent pool is super important, and also Taiwan has this huge amount of resource in hardware business, right, where you cluster together. It's very effective. Yeah.
Thank you, Emerson. Thank you. We would like to turn to Louis for his space industry expertise. So Louis, you've been a manufacturing manager at SpaceX, and can you tell us the story of SpaceX going from 0 to 1?
Oh man. The story of SpaceX, I think, will someday be a movie. I don't know if it's going to be a good, happy ending or not. It's remain to be seen, but yeah, I'm sure it's exciting enough to be made in the movie. I joined SpaceX, I think, back in 2012, when they actually just completed kind of their first successful launch. And you can imagine, I don't know how many of you have been down to LA, and see kind of the SpaceX headquarters, which is really close to LAX. But it used to be a Boeing 747 plant that I think SpaceX inherited. Now imagine 530,000 square feet of space, mostly empty, except with a few big kind of capital machines and a whole bunch of tents. You're like, tents? What is this? That people are sleeping there? No, each one of these tents is actually a work center kind of building a rocket parts. Okay, so I think space is now brand new. Okay, we have gone to the moon, like close to 60 years ago, but I think since then we have stagnated. I think SpaceX is the new kid in town that kind of leveraged and stood on the shoulders of the giants and kind of took it forward. Now, when I first joined, and that's exactly kind of what it's about, like we have a Lowe's right next door, so people literally are engineers owning a specific kind of rocket portions, and they're going to Lowe's next door, buy a beach tent, a few folding tables and some tools, and there you go. This is how you start kind of building a rocket factory from the ground up. So people that have visited SpaceX these days, and looking back kind of where SpaceX, kind of was, kind of starting out to like almost 10 years ago, 20 years ago, manufacturing 10 years ago. I think there's a few key lessons I think that can be kind of taken away kind of for all entrepreneurs out there. One is that your culture and your talents are really kind of what's really going to drive your early stage startup, especially at that very, very early stage. Okay, there's a saying at SpaceX, okay, well, how do you sum up SpaceX culture? Is really just get stuff done. Okay, or you can imagine how Elon would say it, get beep done. Okay, so no matter what, no excuses, okay, figure it out. Now, with an extremely talented group of people that I'm blessed to work with, I think this is possible. So that's kind of a related note is that for startups, it is absolutely crucial for you not to settle for talents. Talents, your company will rise and fall kind of with your talents. Okay, in that early stage, SpaceX was so focused on talent, even though you're strapped for like laborers all alone, but they refused to budge on talents. Every single person that comes to SpaceX is carefully vetted to the point where the final interview after 8 rounds needs to be conducted by Elon himself. So Elon interviewed and accepted every single employee kind of at SpaceX, including our coffee baristas. Okay. Now you might think coffee baristas, okay, what is the big deal? Our coffee barista, I would say, is the world's best coffee baristas. All right. They produce over 10,000 cups of coffee a day. Can you imagine any person beating that record? 10,000 cups of coffee a day. And that's what propelled SpaceX forward. Okay, so even during kind of the deep, dark days, anomalies, budget cuts, all that, I think the one thing that Gwen warns Elon is that you can take away anything, but don't take away the coffee stand. I think people are going to burn down the company without coffee. So that's very important. Okay, talent, get stuff done. And also, as Elon liked to said, okay, if it follows the laws of physics, it's possible. Okay, so follow first principle solutions. Don't set yourself any limitations on framework. Okay, focus on the essence of the problem itself. When I was at SpaceX, I managed 7 departments and over 3,000 rocket parts. One of my components was a super high pressure vessel. Okay, imagine this huge, giant kind of gas tank. Super high pressures, 10,000 psi. Okay, so it's used to propel kind of the entire propulsion system and our rocket launch systems. Now we're trying, this is the highest volume components, and so Elon had a mandate. It's like, okay, we're purchasing this, at an X price, kind of, from a vendor back then. Now this was way too expensive kind of for rockets. So we're tasked with the cost of, kind of obviously cost reductions. So after we did work, extensive, improvements, we managed to reduce the cost down by 90%. We're all very proud of ourselves. We go into Elon, and Elon, the first thing that Elon says, after seeing our presentation, our reduction, is that, you know what? Coke can is a pressure vessel. Okay, go figure out, okay, how they pump out tens of millions of Coke cans at that price. Okay, and then come back, and tell me kind of a better solutions that you come up with. Okay, so we ultimately didn't meet that Elon challenge, unfortunately. Okay, I think Coke can, from a 10,000 psi pressure vessel is just a bit too difficult. But I think that goes to kind of show you kind of the Elon thinking, kind of in terms of and pushing kind of your startup and challenging yourself.
Thank you, Louis. So far, we have discussed the opportunities and challenges for bringing hardware from lab to market today. We have also discussed RISC-V and space industry. So I'm wondering, what are the implications for Taiwan? And specifically for Louis, what are the opportunities in space industry and what can we do in Taiwan?
Okay, when everybody look at the space industries, people like to talk about rockets, right? Rockets gets all the attentions, okay? Everyone wants the big, bad rockets. Okay, but when you look at the entire space industry, launch is only 9%. 9% of the opportunities actually launch vehicles. The remaining 90%, it's actually in GPS, geospatial intelligence, and obviously satellite communication, which has been, the talk of the town these days. Now, the battlefield has also moved from geo to LEO, in which you need more smaller satellites, more inexpensive satellites, that essentially, nothing more than, kind of electronics that, Taiwan builds today. And I think that the current Taiwan supply chains, with its flexibility, agility, and quality, and also expertise kind of in electronics, I think will be very, very well positioned, to capture that portions of the value chain.
Thank you. Emerson, what are the implications for the hardware industry in Taiwan?
Yeah, sure. So about 10 years ago, I had a very interesting dialogue with my colleague. We're talking about how come in the valley, and so I've been in the valley for a long time too, that how come in the valley we don't see any startup in the chip business? I mean, 10 years ago, not right now, right? It's very interesting question back then, right? And then, but you think about this, right? All the software, people go into software business, web business, right? And all the software running on hardware, but how come there's no innovation in the US for hardware? And then how, so where does that software going to run upon, right? And then the answer is that everybody goes to, back then, right, went back to Taiwan or China, right, for hardware business, a particular chip business, right? And then today, there's a lot more innovation going on today, especially with the new CHIP Act, right? There's more government incentive funding coming to play. But go back to Taiwan, we have built such a tremendous amount of resource and capability, right? And even though the threshold is really high today, I don't want to sugarcoat right? The hardware business. It's hard. I mean, that's why it's called hardware business. Right? It's hard. But with this amount of resource and infrastructure we have built out, I mean, the opportunities are there. And then I'm sure that I'm Taiwanese, and then I think we can keep going, and then we can keep the success for a very foreseeable time frame. Yeah.
Thank you, Emerson. Finally, let's go to Michelle. Given what we have discussed today, what are the implications for the hardware industries in Taiwan?
Okay. Yeah, so I think echoing the other two panelists, I really believe that right now it's really like the best time ever, to start a hardware company, just with all these spending that both in the public and private sector, right? The CHIP Act, Infrastructure Act, and the Inflation Reduction Act in the U.S., and then I'm sure in Taiwan some similar efforts as well, and national development funds. There's just lots of capital that it's required, to bring these, hardware, hard tech innovation to market, and there's awareness and willingness to invest at earlier stage, in part driven by just, again, we talked earlier about like really climate change sustainability has really now become, generally acknowledged. Still not 100%, but people are aware and then understand that the clock is ticking. We have very little time. So I would say that this is the best time and also the critical time to start in this space. Lots of opportunities around, both in terms of resources and funding, both private and public. For Taiwanese startup, I would encourage you, going back to my earlier point, really think big, right? Really think about the large problem that's facing the world today, because we don't live in isolation, right? People living in Taiwan are affected by the climate change caused by people living elsewhere in the U.S. and whatnot, and vice versa. So we really want to look at the problem from a global scale, but act locally, thinking about what's my advantage in Taiwan. We have the manufacturing prowess, we have the supply chain, we have a lot of hardworking people willing to give it a try and bring technology to market. So just think about how to match the big problems with your capability, and try to build a team to bring that to reality. And that's the team members, as Luis mentioned, that's going to come in to help you to do your data operation, including the baristas, and as well as your investor, right? Looking for the right partner that will help you through thin and thick, and have the capability and understanding, and will really support you, like NDF did for Emerson's company. So that's that.
Thank you, Michelle. And I would like to thank all of our panelists for sharing their insights. Audience, please join me in thanking our panelists today.